Thank you for joining us today. Today we'll be discussing in this webinar is the changing landscape of cellular communication technology and what it means to you. Again, thank you again for joining today. My name is Greg Hazen. I'm from the Product Support Group. If you have more questions, then hopefully we'll answer them as we go through this webinar. In today's agenda, we're going to cover the differences of technology. Why is 2G being discontinued? Our ISCO's LTE solution and overview, and how service and installation information is done in our devices. First, we're going to go over is what is the difference between CDMA and GSM. CDMA stands for Code Division Multiple Access. GSM stands for Global System of Mobiles. These are two different technologies or networks that you will find in the United States and worldwide. Why would you choose CDMA versus GSM? Well, CDMA is mainly located in the United States. Verizon, Sprint, several other companies use what is that CDMA technology, whereas GSM is more of a worldwide network solution that you'll find for cellular networks, whether it's AT&T, T-Mobile, Orange, or Singular, or Rogers, or Telus, or Bell, all around the world. When GSM and CDMA came out initially, the European area chose to use GSM as their standard, whereas the United States, they chose to not decide between CDMA and GSM. That's why there are still two different technologies used in the United States. In truth, neither of them is better than the other. It all depends on where your area of service is and who you may have accounts already set up with. Maybe your company uses AT&T or T-Mobile. You would probably go with GSM cell phones for your network of devices in the field pushing data. Now, if you use Verizon, you would probably use Verizon as your carrier just because the rest of your accounts are that way as well. Our CDMA provider here at ISCO is Verizon. We don't do any other like Sprint or anybody else that does CDMA. Our devices are licensed and are allowed onto the Verizon network. Whereas with GSM providers such as AT&T, T-Mobile, or Rogers, that you can use pretty much any of those as long as our cell phone is provisioned for each one of those networks as well. The other thing you will find is based off of where you're located is which type of service you would choose to use, whether it's Verizon or AT&T or T-Mobile. Verizon is a lot better service for a lot of the country, not in the mainly metro areas, such as say Los Angeles or New York or Atlanta have great GSM, AT&T, T-Mobile coverage, but out around Lincoln or off the interstate here, very limited GSM coverage, but great CDMA coverage. So where you're located geographically will drive which technology you would use as well. So why is 2G being discontinued? 2G cellular technology was introduced around 1990. And per Verizon's decision, they're going to be active until December 31st of 2019, after which time that will be discontinued. LTE, which is the 4G or Verizon's new solution for their network, came out in 2011 and has evolved over time into different versions of LTE, whether it's Category 1, 4, or Category LTE-M. Now, each one of those categories has different speeds and different uses you would find. So like LTE-M, you might find on some of your network devices that like your refrigerator or your microwave or whatever other devices in your home that require low amounts of power or just small amounts of data usage. The The LTE 4G is also about 1,000 times faster. So something that would normally take, like browsing a web page, about 0.1 seconds on LTE could take 3, 4, or 5 seconds on a 4G or on the 2G network. Downloading pictures, which could take a minute or so, will take multiple minutes on 2G. Everybody's probably seen this if you go with your cell phone into a coverage area where you lose 4G. Even down to 3G or 2G or 1XRT, you notice your phone really slows down. Or actually, you can't even go to the web pages because it just is too slow on its loading the pages. Another reason that Verizon is discontinuing 2G is over 92% of their network traffic is now on the 4G LTE network. So as you can see, a majority of their traffic is already there. So they are wanting to get rid of the additional expense or maintenance on those older 2G networks when most everybody is already on the 2G or 4G LTE network. Also, the LTE network uses their network frequency spectrum much more efficiently than 2G, so they're able to pack a lot more devices into the 4G versus the 2G network. The 2G network also is being shut down to open up those frequencies for future use, maybe by additional versions or generations of the network traffic. All companies, whether it's ISCO or other flow service providers or even just other companies that use cellular technology for data transmission, have to come up with some solution because of the 2G shutdown by Verizon. So it's not only our devices, it's a majority across any different number of industries are having to deal with this at this time. The selection of whatever type of LTE version, whether it be category 1, 4, or M, is all based on the applications of what kind of devices you have, how much power consumption is needed for those devices, and how much data bandwidth or traffic or speed are driving factors in which version of LTE you would want to use for an application. We have chosen to use the 4G LTE is our solution for text messaging. For the capability of the modems of 4G LTE have the ability to send text messages directly from the meters, so they are able to alarm if a certain condition has been met. So you have an overflow in a sewer or in some sort of pipe situation where you wanted to monitor the level and receive an alarm based off some condition, you can receive a message directly from the meters using the 4G LTE text messaging. The LTE-M, which is a lower power, higher speed than the LTE, but the problem with that is it does not allow the ability to send text messages directly from the meter. So looking at that, we looked at both of those or multiple versions of the LTE spectrum to see which we'd like to do, and we determined that we believe that the messaging for the text messaging based off of alarm conditions is a very important part of our customers' business use of our devices. So we've chose to use the 4G LTE. One of the changes you'll find with the new 4G antennas is that all the LTE antennas require a higher frequency. So all of our 4G LTE antennas, to differentiate between the older version 2G versus the 4G, the new 4G antennas will have a white connector end that you can see here in the circle. All the older ones are black. So as you see that you have a white connector end, you would make sure you'd want to use that with the new 4G modems. The older antennas will work with the black connector. They will work with the 4G LTE modems, but they are not optimized for the 4G spectrum of the signals. So you want to make sure that you use the new white connector end when you use the new modems. One of the differences that you'll find when ordering 4G modems or new LTE modems is that we no longer have to pre-activate prior to shipment from ISCO. The customer, you would just need to contact Verizon and purchase the SIM cards. So everything with the LTE modems will require SIM cards to activate the service in the modems. So you would need to contact Verizon to get those SIM cards. When you order or contact Verizon, you would need to tell them you need a M2M plan with text messaging enabled if you plan to get messages from the field. If you wanted to be able to contact the modems remotely using an IP address, you would need to also request that you get an unrestricted static IP address when you purchase that. Now here's some of the differences between the different types of SIM cards that we can use inside of our devices. There's the standard or mini SIM or the micro SIM card. The micro SIM is the one that is typically shipped by Verizon for these modems. So that would probably be more likely the one that you receive from Verizon. The nano SIM card does not function. We don't have a way of inserting that properly into the modem, so do not request a nano, request a micro or mini. So looking at the 2100 devices, so the 2103 CI LTE or 2105 CI LTE, all the modems will have an opening in the bottom side of the module for inserting the SIM card. What you'll find is that that metal door, you can use a large screwdriver or a quarter or some coin to rotate and open the cover to access the SIM card inside. What you'll find looking into the opening that you've done is when you first get the unit, you'll find an adapter on the end of a ribbon cable, which also contains a micro SIM adapter, or to allow you to put the micro SIMs in or just slide the mini SIM in without having to use the adapter. So here's an insertion of the mini SIM. You'll see a drawing on the cable itself showing you the correct orientation to place the SIM card into the adapter. Once you've inserted the SIM card, you'll stick it back into the bottom on the circuit board and then close the box back up. If you did get the micro SIM, you'll need to use the adapter, or this micro SIM holder card, to insert that into that adapter as well. So you'll see that you can just insert that micro SIM into the adapter and slide it into the same slot. In the future, that ribbon cable is going to have the capability of just having, will accept micro SIM cards on their own due to the limited amount of mini SIMs that Verizon has been sending out. They always send out micro SIMs. So to make it easier, we're going to be removing the adapter and making it just simply be a micro SIM connector on the end of the ribbon cable. Here you see the micro SIM using the holder slid into the end of the adapter cable on the inside. The next step you'll need to do once you have inserted the SIM card is to connect with FlowLink to the device and set up the modules. Now, with the APN number is now required on all Verizon AT&T or all Verizon LTE modems. The APN number is an access point name, and it's dependent on where you're located in the United States. And it's also one of the APNs you use is based off of where the phone number originates for the account or the cell account number that you have. So if your cell phone account number that is on there is located, say, in Nebraska, we would use MW01.VZW static. That would be our APN number. Now you would want to make sure you, it doesn't really matter if it's capitalized or not from everything in here, but we would just use WE for the western portion of the United States, MW, SO, or NE. And the third number is always a 0, so don't put an O in there. But you would put that in if you had a static IP, unrestricted static IP assigned to this SIM card. If you have a dynamic APN, or dynamic IP, I apologize, the following APN, VZW Internet, is what you would use in place of the static IP APNs. Now looking in FlowLink, for when you've done your connection with FlowLink and want to install the APN, you would click on the modem tab. If you've been using Verizon phones for years, you'll have never probably used this tab before, but it is required now that we get that APN put in so we can make connection to the network. So what you'll find is you'll find an APN slot there. So you're going to type in the APN that is in your area for your location. Next thing you also need to do is to make sure we can get onto the network after you've installed a new APN number is to cycle power. So disconnect with FlowLink after you've applied and disconnect the power, disconnect it from FlowLink, cycle the power so that then the module is able to provision itself on the network properly. This is a quick look at the screen within the signature flow meter, which is pretty much the same process here, but you just go to menu, hardware setup, modem setup, and you'll type in the access point name or the APN that, again, fits where you're located in the United States for your Verizon service. Once you've done that, you would cycle power on the signature meter, and when it comes back up, it will provision itself on the Verizon network. Now, in the past, there have been some different ways that modems were ordered, and we would wait to get the service in, and then we would ship it once you had set up the service with Verizon and we had tested it, but we don't have to do that anymore. So now, when you place your order with our ISCO customer service for your modems, they will place your order and then ship you your modems. Once you receive your modems, you will contact Verizon with the IMEI number, which is located on each of the modules and modems, to give that to Verizon to set up the service. And again, you're going to ask Verizon for an M2M plan with text messaging enabled and an unrestricted static IP address for this version of modem called the NimbleLink Skywire. So if you give them that information, they would be able to set up your account and send you or get you the correct SIM cards to activate your service properly. They will then send you the SIM cards that you see here. The micro SIMs most likely is what we see. You'll install the SIM cards like we went through inside of your modems and connect the correct antenna that has the white connector end. Then you would connect with FlowLink or log into the signature meter to put the correct APN for your location. Cycle the power on all the units or whichever units you're working on. And then you can test that you have successfully seen a push of the data to your server, or you're able to contact the modem or the module via the static IP address you set up with Verizon. Now, if you run into problems, first thing to check is to make sure the SIM card has been inserted properly into the modem. You have to make sure that it's seated properly, maybe pull it out, put it back in again, just to make sure it seats in properly. The next thing is to make sure you have the correct LTE antenna connected to it with the white connector in. Verify that that's what you're using with that modem. We want to see signal strength greater than 20%. So if you find that you're not reading good signal strength with your antenna signal strength when you're connected with FlowLink, maybe move to another location wherever you're at just to see if you can get a better signal. Make sure you've installed the correct APN for where the phone number is originating from. And next thing is to maybe contact Verizon to make sure they've set up the M2M plan with text messaging properly so that you're able to access the network. Another thing that you could try is maybe the service in your area has an issue. You could take, if you have a modem already working out in the field at some location, swapping this LTE modem for another one that may be working, just to verify that the problem stays with the modem or stays at the location to help troubleshoot that problem. If the problem still persists, one thing you can do is contact our product support group. We are happy to help out. You can contact us at 866-298-6174. Now, just looking at some of the future communications, we're looking at some of the emerging technologies for communications. There are a different wide variety of other than cellular networks out there. There's the low power wide area network, or LPWAN. One of those is LoRa, which stands for long range. It's more of a radio frequency versus a cellular frequency. Sigfox is another type of radio frequency used in certain distances, but allows you to not have to be using a cell phone, but to allow you to use a radio transmission instead. Another one of these is the low power cellular wide area network, or the main one is the NB-IoT, which is narrowband Internet of Things. Now, things like the Internet of Things is you will find in modems that have been installed in, say, your refrigerator or your microwave or your dishwasher or your thermostat at home, that allows you to communicate with these devices or get data from these devices just in short bursts, or that kind of information, just as another way of transmitting between devices in the field and getting that data in for you to be able to work with it. One of our other devices that does have some of those capabilities already is the accQlink. The accQlink is an ISCO device here that allows us to have multiple sensor inputs, whether they be from Modbus with ASCII or RTU, from RS-232 or RS-45, or SDI-12 input, contact closures, such as rain gauges or alarms, analog inputs, such as 4-20s. Those allow you to bring all those different devices into the ISCO accQlink and push the data to the ISCO accQlink cloud. Via how it connects to the network is through a global SIM card. The global SIM card allows us to use AT&T, T-Mobile, and Verizon all in one module here without having to switch out any cards. It automatically comes with those when you purchase the unit. Gives you all three of those services, and what the accQlink will do, it will look at the services that it has and find which has the best signal and use that. So if you have great AT&T coverage in your area but horrible Verizon coverage, it would choose to use AT&T. Now, if you moved it to another location, it would start using Verizon if that service was better. It does come with some of the LPWAN options, so you're able to use some of those low power wide area networks such as LoRa, Sigfox, those kind of things if you purchase it with that option. The data, again, is hosted on the accQlink cloud via a web server, via a web page that you're able to access your data and pull that down and work with it locally if necessary. It also comes with alarms, features of being able to look for certain thresholds or some sort of condition to occur. You can receive text messages or emails that will allow you to know that some sort of condition has occurred. And I want to thank you today for joining me on this webinar. I hope it was very informative for everybody. If anybody has questions, you're welcome to contact the product support group or customer service or your reps in your area.